Alright, these are going to be a few steps, clues, and just information about momentum problems to help you with the AP exam.
Clues that will tell you if you are doing a momentum problem. If the problem mentions collisions, it's almost certainly a momentum problem. There's more than one moving object because you need two objects to collide into a thing. Impulse is mentioned because that's change in momentum. And as for variables that you're given, time and force, or mass and velocity.
Alright, so here are going to be the relevant laws and definitions for momentum. The law of conservation of momentum is of course going to be the first one, and that is that the total initial momentum of a system is equal to the total final momentum of a system if no outside forces occur in the system. Impulse. It's the change in momentum of an object caused by a force acting for a certain time. So you can find this in the law of conservation of momentum, and that is going to be impulse. It is going to be something that changes the momentum. So if the initial momentum does not equal the final momentum, that means there is impulse. Here are the types of collisions, and I will show you these afterwards in a video. When elastic collision is when two objects collide and go in separate directions. One can also stop. And an inelastic collision when two objects collide and release some type of energy. So kinetic energy will not be conserved in this. Perfectly inelastic collision when two objects collide and stick together and move as one after the collision. That means they get stuck together. That means both of their masses are connected in the final momentum of the system. Explosion, when no initial momentum of the system equals two equal and opposite final momentums of each object. There is not momentum coming from nowhere. The momentum is just canceled out by each object. Alright, so this is the explosion collision. Watch it in full speed, and I'm going to do stop and go. Notice that they start with zero momentum, and they both end up with momentum, but one is a positive momentum and one is a negative momentum, so they are equal and opposites because there is no final momentum, because this one is moving equally and oppositely that one, therefore there is zero momentum. Alright, in this next one, it is going to be an elastic collision. Now watch it in full speed. Notice how they do not touch at all, so no kinetic energy is lost. Also notice that this one stops, which is technically is the opposite direction of this one, since when this is moving positively and this one is not moving positively with it. Therefore, it is an opposite direction. Alright, this is going to be the inelastic collision. I'm going to play it in full speed and kind of just explain what happens. What happened was, this cart put a force on another cart, which that cart then had initial momentum. The final momentum, though, has the mass of the second cart because they combine into one piece, one part for the momentum. So the velocity does decrease.
The most common way to solve momentum problems is to use the law of conservation of momentum. The initial momentum of the system plus impulse is equal to the final momentum of the system.
Alright, here's a common approach for a conceptual question for momentum. As fuel burns, the mass of a rocket decreases if at a certain point the mass of a rocket is half its original mass and its velocity is twice its original velocity. How are the momentum and energy affected? Momentum is mass times velocity, so if the mass went down by a factor of 2, the velocity also went up by a factor of 2, nothing would change. It would be unchanged. So we can cross out this C, D, and E because momentum is not at all changed. Energy, kinetic energy specifically, is changed because the original mass may have gone down by half, but kinetic energy is 1/2 mass times velocity squared. That means that this 2 in front of velocity will be 4 because it is squared as well. The 2 is also squared. So that means that A will be wrong, B will be your answer because momentum is unchanged, yet kinetic energy is doubled.
Okay, so here we have a common type of experimental problem for momentum. It says a 5 kilogram ball is rolling to the right at 6 meters per second when it collides with a stationary ball of mass 3 kilograms. The 5 kilogram ball collides with the 3 kilogram ball in a perfectly inelastic collision. So that means that when they collide, they're going to stick together and then both roll together. So it says, what would happen to the final velocity if the following variables were changed? The 3 kilogram ball is initially moving to the left. So if the 3 kilogram ball is initially moving, then it's going to have a negative momentum. So the initial momentum of the system is going to be less than it is in the original problem. So the final velocity is going to be less because the final momentum is going to have to decrease. Next it says the velocity of the ball in motion is doubled. So if the velocity is doubled, now it's going to move at 12 meters per second. And if it has a greater velocity, then its momentum, its initial momentum, is going to be greater. And so it's going to have to increase the velocity at the end so that the final momentum will also increase to match the initial momentum. Okay, so for the last part of this problem, it says the first ball does not stick to the second ball and moves in the opposite direction. So now after the two balls have collided, they're going to bounce off in opposite directions of each other, which means that now we have a negative momentum and a positive momentum after the collision. So the ball moving in the positive, or that has a positive momentum, now has to have a greater velocity because the momentum of the ball moving in the positive direction now has to counteract the momentum of the ball moving in the negative direction and be able to maintain the initial momentum of the system.
Alright, this is the final common approach, which is calculations. A 500 kilogram car is rolling down a hill and leaves the hill at 5,000 meters per second. The car hits a tree and the collision from start to finish lasts 5 seconds because of the airbags. What is the force that would act on a 50 kilogram person? Well, first start off, let's use the law of conservation of momentum. Pi plus j is equal to Pf. The Pi is going to equal the mass of the person times the velocity, because the person is also going the same velocity as the car. And that would be 250,000 plus the impulse, which is, since there is no final momentum, the final momentum is 0, that means there must be an impulse enacting, and it takes 5 seconds long. So the force is going to be equal to negative 250,000 divided by 5, and it's negative because it's on the left side. We have to move it to the right, so we must subtract it. So yes, it will be negative 50,000. That will be the force enacting on the person. Alright, the next part is what would be the force if the car was equipped with special airbags that increase the time to 10 seconds. Now, if the time was increased to 10 seconds, that would just be like using the impulse, except for changing 5 with 10. So it would just be, instead of negative 50,000, it would be negative 25,000. What would be the force if the car's mass was increased to 1,000? It would be the same as if it were up here, because the car's mass has nothing to do with the momentum of the person. Alright, now everybody knows what you will see on the AP exam for momentum. You will know all the clues, you will know step 1 to step 70. Hope you enjoyed.